Welcome all. Welcome to the lecture, the design and analysis of algorithms. Today's our topic is P and NP, polynomial and non-deterministic polynomial. So we are working on the introduction of what do you mean by P and what do you mean by NP, why it is important, and what is the current stage and how can you able to see the difference between the P and NP. So if any problem given to you, can you able to tell whether it's a P problem or an NP problem? Can you able to classifying that? So that's what we will do in this particular lecture. So let's start with motivations. So there is one famous problem, we call it a Millennium Prize problem. So that was given by the Clare Mathematical Institute in the 2000, and it is in terms of 7 problems in the mathematical areas. So, well, as of May 2020, so in this present day, 6 of the problems remain unsolved. Only one problem is yet solved, and somehow the person who is a winner take no to the prize money, but anyhow they solve the problem. So you can see that you will solve one problem and you will get 1 million US dollar by that institute. Even you can check whether the in the today either you get the money, if not money then you will get the reputations or both. So you will be updated on the Clare Mathematical Institute website to check what is the current status of the problems, what is the prize money and how to solve. Even they have given a very good guidelines that if you somehow solve any problem, then in which way you solve them, the answers they will be able to check it out, and if you are lucky you will be getting 1 million US dollar. And in terms of Indian rupees, well, I think now you can able to count the number of digit. Okay, so 1 2 3 4 5 6 7 8 digits. So you solve the problem and you got it. Now why we are interested in this thing? It's a mathematics problem, it's by yet unsolved, so and so on. Well, this is what our interest. One of the unsolved problems from these 6 problems is the P versus NP. Yet people are checking whether P equal to NP or P is not equal to NP. That is the one of the 6 problem that is yet remained unsolved. So maybe after looking at this video lecture you will be self-motivated to check in the further details, and I will be very happy that if one of you will able to try to solve in this particular directions and try to get some better results and try to make it more foundations. So first question, what do you mean by polynomial time algorithm? So as it suggests, the main criteria is this n raised to k. So you can go with any algorithm. Let's say if you are taking a quick sort, it's either n square, n log n, whatever. If you are taking in terms of merge sort, it's n log n. So now the log n is in terms of n, so that's why you have a some bound. Even n log n is kind of less than n square. So that's what you can say is some n raised to k power in terms of big O notation, that you can try to represent that thing, because log n is dependent on n. So that's why n log n you can write in terms of big O of n squared. So that's why it n raised to k. So you have an input of size n, you have a some constant k that you will try to utilize, and then you try to solve the problem. So all these problems that belong to this category, that's we call the PEAT algorithms or the polynomial time algorithms, because they are solvable in this thing. Now the next question is, well, if all the problems still in this world, are they polynomial time algorithms? Well, the answer is no, because there are a set of algorithms that is yet not solved in this time n raised to k. Okay, one of the problem is the famous by the Alan Turing, the halting problem. It means that you will give a particular piece of code to a machine and you will check whether the machine will be stopped or it will be run continuously, so and so on. So that is a halting problem, whether the machine is going to be halt or not. So that is not a polynomial time algorithm. You cannot say whether it will within a given time you will get answers. Okay, so you have to depend on the machines. That is what this thing. Now the second you will try to revisit the greedy algorithms in terms of the fractional abstracts, in terms of the shortest path algorithm, in terms of the minimum spanning tree, everything in terms of if you decide the input is in terms of n, the n number of nodes or up to the n number of edges, so and so on, then your answer will be in terms of n raised to k, something that you can able to bound. That is what you can do. So all this thing, if you somehow convert in this n is the input and the running time in the big of n k, then that's you answer as a polynomial time algorithms. Okay? So now our next problem is NP complete problem, non-deterministic polynomial time complete problem. Yet we don't know whether there is any polynomial time algorithm that is yet available or discovered to solve this particular NP problems. That is what the things NP complete problems. Okay. So now that was a famous questions whether P equal to NP or not. It means those problems that is yet not solvable in a polynomial time. Can you tell that in future also there will be algorithm available that can be solve this thing in a polynomial time algorithm? That is what the question here is. If you can able to prove that either they are both equal or they are not equal. So that is one of the research problems, and people in the computer science throughout study they are using this thing. Now what is the advantage of NP complete problems? You will say that, well, if this type of problems are available where there is no any efficient algorithm, the word efficient is very helpful in this way. The word efficient, it means it can be solvable in a given time. So that's why the question is, what is the advantage of this type of problems that if we cannot solve in a given time? Well, you can say that if you cannot solve in a given time, then you can use for a security purposes. In the security domain, people want to use the problems that cannot be easily solvable by the attackers, because in a security domain, attacker is an entity having a powerful resource. So if even with a supercomputer, if attacker cannot able to solve the particular problem in a given time, then there is no meaning, it's a useless for an attacker, and that is what the useful for the people, those who are using this thing. So that's why the disadvantage that we thought of an NP-complete problem, that will be an advantage in many domains, and one of them is the security, that people try to utilize this type of problems. That is one type, one way, or reversible, that is not that much possible. That's what it can do. So now we will see a list of problems in which the first problem sentence that will be a P problem, while the second set of problem that is NP complete problem. The both looks a kind of similar, but there's just one change is boom. Now the shortest and the longest path. So given a graph, you can take either, let's say you will be given a graph of a cities and the edges, and you have to find the shortest distance. That is what the P problem. You can use the just the shortest path algorithm, Floyd's algorithm, anything that you can able to use it. But if the same question will be asked in different way, that okay, now in a given graph between these 2 points you have to find a longest path problem. What is the longest path that is possible? It will take maximum time and the distance. Now you can say, what is the application of longest path? So you can see that sometime if you go to some taxi and the people will be very kind of, that way, that try to take a longest route to your destination, so that if that is a meter based, that if you are taking a kind of vehicle, so the meter will be on a time of distance that you travel. So if they will take a longest path, it will be a more kind of income from that. So that's what you have to take care, that the applications of a longest path and the applications of a shortest path, that is both will be there. So one problem, shortest path, that is a polynomial time problem. Second problem, that is the longest path problem, that is NP complete problems. Okay, so that's why, yes, when I take a higher book, okay, you have to make sure you have to check out the shortest path distance, and the moment the person will take you to the longest path, you will tell them, oh man, you are taking me in a wrong path, So please make sure this is the shortest path that you to take part. Okay. The second problem is the Euler tool and the Hamiltonian cycle. So now what is the Euler tool? That in a given graph with edges and vertex, you have to find a particular path that will visit each edge only once. So that is what the Euler, that is a polynomial time algorithm, while the Hamiltonian, that is just a kind of reverse twist. In place of an edge, now you have to visit each vertex once. That is what a Hamiltonian path problems. And even the broader version of Hamiltonian path problem is a traveling salesman problem. So consider there is a one salesman who want to visit a certain place. After visiting a certain place, the person again come back to the place from where they started. So even you can consider a courier person's option. The courier person have to deliver, or the postman have to deliver many particular posts at different particular places. Now they have to make sure that whatever the vertex that they will take, they don't have to again come back from that vertex. So they will come. So again they will reach from where they started, and the entire path is kind of optimal or the minimum. That is what the traveling salesman. So the broader version of the Hamiltonian will lead to the traveling salesman problem. And you can see the Hamiltonian is NP complete problem. So just one simple twist by looking at the problem definitions and by looking at the algorithm, there is vast complexity. That is what the things that make this thing unique. The second thing after next, 2 CNF and 3 CNF. Conjunctive normal form. In our world, you can use it AND, OR, and the NOT gate. So what you can see here is, if it is a 2NF, so now 2NF means this number of brackets can be any. So right now there are 3 opening and closing bracket we are using. In every bracket you have only 2 allowed, that is with a OR gate, and between these 2 brackets you are allowed AND gate. And now your task is to find the Boolean values of x1, x2, x3 such that this particular formula will lead to you to the 1. Okay? So now you can see there is a one assignment that x1 is 1, x2 is 0, and x3 is 1. So now you will put as a x1 as a 1, this is true, yes. X1 and x3 is already 1, so this is 1, good. Now x2 is 0, so this one is a 1, is a negative, again it's a 1, so 1 and 1 and 1. Wow, it will be a 1 because AND gate, if all inputs are 1s, your output will be 1. In OR gate, if one of the input is 1, your output is 1. In the AND NOT gate, whatever is the input value, you will negate the value. If it is 0, it's 1 as output. If it is 1 as input, it will be 0 as output. So that is what this thing do. So this particular input will lead you to the output. So this 2NF is the polynomial time algorithm, while 3NF, in the 3NF, now in this all the brackets you have a 3 literals, and that you will try to OR and then the AND, and the only thing is it can be any number of the sequences possible. So now this particular problem, that is a NP complete problem. Okay, so that's what the thing you have to check it out. Okay, so let's go with the 3 class P and NP complete. One is the P, that's we all know. The problems that is solvable. The word is very important. The word is solvable. We are not interested in just answer. We are working on the algorithm that solve this given polynomial time. So any set of problems like shortest path, it means you can give any graph that is give you the shortest path. That is what the thing is here. Now the next is NP, non-deterministic polynomial. The word here is verifiable. Yeah. So verifiable, it means if we can give you the solutions, you can able to verify whether it's a solution or not. Like if I go to the previous case, let's now here, if it is a 3NF also, if we can give you any particular assignments of x1, x2, x3 of anything, can you verify whether it's a solution or not? Yes, you can put the values and you will check it out whether you will get 0 or 1. If it is 1, it's a solution. If it is 0, it's not a solution. In a given polynomial time, you can able to verify whether this solution is correct or not. So that is what the class NP. Yeah. So now it's very obvious all the problem in P is also in NP, because if you take any particular list of problems in a polynomial time algorithm, if you can solve, then you can verify in the polynomial time algorithm. That is what makes the P is a kind of a set in all NP. So all the P problems are already available in NP. Yeah. So for more details, you can check it out the books on the algorithms. You can check it out the video lectures and other relevant material. You can check it out also on the Google, the P and NP. So I hope that this particular lecture will try to tell you what do you mean by P problem, what do you mean by NP problem. Also, we have visited certain P problems and certain NP problems. So now if we can somehow solve those NP problems in the polynomial time, then we can kind of claim that P kind of equal to NP, or we can claim that P is a subset of NP, or what. So that is what we have to make a claim. And if you can able to solve, then that is my best wishes. Though I'll be very happy that in my next video lectures in this particular, or to my students, I will use your name that okay, you have solved this millennium problem. Okay, welcome everyone. Thanks for watching this video.